بسم الله الرحمن الرحيم رب زدني علما.
So now in this section, we'll be discussing about the SD access operational planes. So probably here, I'm just giving you the quick overview of different planes. But as we move on in this section, we will try to understand each and every plane differently. Okay. So the first thing, SD access operational planes, it basically refers to the different tasks or the operations doing different functions. Like whatever the functionality of the device or the architecture, which is going to contribute the complete overall network management, security, and other things. So these all divided to different planes. We call them as operational planes. And we'll try to understand how it operates at different planes. So the SD architecture, how it works in each and every plane. So again, the prerequisite, I expect you to know a little bit overview of the control plane, data plane, all these options. So if you just quickly review as the different planes here, like let's say you have a device, it can be a router, switch, or any other device. So we can divide this operation of these devices can be like we have a data plane, and then we have a control plane, and also we have a management plane. Now, if we compare the functionalities, data planes, let's say control plane is responsible for building a database. And this database is used for forwarding the traffic. Like in terms of router, you can say a routing table is built based on the OSPF or any routing protocol. And we can verify that by using show IP route. And based on this routing table, it is going to forward the traffic. Now, again, the actual forwarding is done by the data plane. So data plane will do the actual forwarding job. And it's going to check this control plane database. And depending upon what is the next hop, what is the exit interface, it's going to forward the traffic. So the data plane deals with more, the actual forwarding of your traffic is deal with the data plane. The control plane deals with building the database, which is used in forwarding the traffic. Like in the case of switch, we can say like STP information or VTP, other informations. Now, again, there is something called management plane. Now, management plane refers to the management related tasks like you can say like telnet, SSH, or graphical interface you access, or NTP or syslogs. So these all services comes under the management plane. So management plane refers to the services which are used for the management functionalities. So this is just a kind of a quick review of the different planes. Now, similar way, like I expect you to know these foundations. Probably in our previous sections, we already covered that in the foundation topics, in the SDN topics as well. So now if you divide the same thing in the case of SD access, we have a control plane. Now control plane again is responsible for building the database. And this database is used to make the decisions to forward the traffic, right? So what exactly the control plane job? Control plane is responsible for building the database, which can help in making the decisions where and how to forward the traffic. That is typically the functionality of the data plane, right? Now, here, this job is done by the protocol called LISP. So we have LISP. Basically, that is kind of a locator ID separation protocol. And this protocol works at the control plane. And this is the main protocol for communication and the messaging protocol inside your infrastructure. So the routing table, just like we have a routing table, which is having the complete information about the destination route. Similar way, the LISP also responsible for maintaining some information, which will be used to tell where and how the forwarding should happen. Okay. So again, as I said, I'll be getting into more in detail about the LISP protocol and the functions, how it works more in detail a bit later on. Now let's move to the next one. Now we have something like the data plane. Now the data plane refers to the actual forwarding of your traffic. So the actual forwarding of your network traffic is based on the decisions or the database which is being used. So it's going to forward based on the control plane information. So it mainly deals with actual forwarding of your traffic. Now again, similar way here also, if you just try to compare the data plane traffic in the case of SDA architecture. So in the SDA architecture, again, we have something like VXLAN. So VXLAN is again based on the data plane, virtual extensible LAN. That's what it stands for. It's one of the key technologies used for encapsulation of your data, as well as the decapsulation. So as the traffic moves from one point to another point, there will be some kind of encapsulation is done. And that is what done by the VXLAN. So the actual data forwarding is done at the data plane with the help of VXLAN. And this VXLAN is responsible for encapsulating your packet with some information, adding into the header. And based on that information, your data is being forwarded. Again, also separated many things at the backend. Okay. So the second protocol is VXLAN we need to understand. As I said, I'll be going through with this protocol a little bit more in detail, probably in separate topics. We'll be getting into that. Now, again, coming to the management plane, let's go with the management plane first, which we already know. Now, the management functionality is more into management related tasks, which is more into kind of a configuration of your devices, like whenever you telnet or SSH. Of course, here we use a GUI interface. From the DNS center, we will be logging into the GUI, and we'll do the configuration so that the same configurations will be pushed to the devices. At the same time, we also do the monitoring from here, as well as troubleshooting all these things we do from a centralized place. So the entire orchestration part and the visibility of the network, management of your network, everything is done by the DNS center, which is going to be the main component for doing all your management related tasks. Like I said, it's going to do multiple things: visibility of your network for monitoring, as well as facilitating the complete management related task. Okay, so basically the administrators will be using the DNS center in order to be able to monitor as well as to configure the networks. Now, there is one more thing called policy plane, which is something we use here. Of course, the policy plane, we have something like Cisco TrustSec is going to use. First, let's see what is policy plane exactly does. But the policy plane is going to define the policies which needs to be applied to the devices. Like policies means, let's say, what traffic they can access, what the traffic they should not access, or which virtual network you need to assign that particular device. Now, this is completely done based on the identity, based on the user account, or based on the device types. Like if the device is a VoIP device, then it's going to assign to the virtual network, which carries the VoIP traffic. If this user belongs to marketing department, it's going to assign to the virtual network so that he can only access the marketing department. So basically, you will be configuring some policies like authentication, authorization policies will be applied. And also another example we discussed as well, like the guest user should be able to only access the internet, but not the other things. And also you need to apply some, these are all security policies, which is going to dictate what level of access you want to provide and other configurations. So this is completely done based on the identity or based on the device type, or even you can do it based on the location, is all the things. Again, at the backend, it's going to use the Cisco ICE with some Cisco TrustSec feature, which is being used. Or we can say like Cisco TrustSec is kind of a framework which is going to provide all these things, like providing the secure access, or the network segmentation, these are all the things. And it's going to assign some kind of attributes to the devices. And based on that, it's going to apply the policies. So the policy configurations is done from the Cisco ICE with the help of Cisco TrustSec feature, or that's the kind of functionality. So overall, the functionalities of your SDA architecture can be divided into 4 different planes. Each plane will do a different kind of job. Like I said, the control plane is basically building the database. And based on this database, it can identify where that particular destination device is. And that database is built by the protocol called LISP or LISP. And likewise, the data plane will do the forwarding job. And for that, there must be some kind of encapsulation, adding some information, source and destination addresses so that it can be forwarded. And that encapsulation is done by the VXLAN. Again, the policy plane is responsible for enforcing the policies, like authenticating and authorizing what resources they can access. And finally, the management plane is responsible for pushing, provisioning the devices or monitoring or any kind of configurations we do. Basically, that is done by the management plane with a Cisco DNS center.